Hello, and welcome to another X-Pro tutorial for SolidWorks modeling. In this tutorial, we will be creating a model of this metal housing for some sort of device that needs cooling. We will begin by making a new part. As always, we will be using millimeters for drawing. So basically, what is sheet metal? It's a part you can produce by cutting a specific shape in a metal plate and then bending it in specific places to create something like we have here. SolidWorks has very good tools for creating sheet metal parts, and we will learn how to use some of them today. So let's start by creating a sketch on the front plane. I will use a line. Let's make a shape like this. We'll make this line vertical. The center of the horizontal line and the origin are going to be coincident. This line here is supposed to be 70 millimeters, the same as this one, so we will make them equal. The horizontal line is 250 millimeters long. This one here is 35, and so is this one here. These two can be equal. And now instead of going to Features Extrude Boss, we will go to the Sheet Metal tab and select this. It basically does the same thing. So let's take a look from the front. What we can do here first for direction is the same. As for the Extrude Boss, we will select a midplane and make it 300 millimeters. Then here, it's asking about sheet metal parameters. You can see that this yellow line is increasing in thickness, but we want it to be 2 millimeters. And this radius is the radius of the bends. We want it to be 2 millimeters also. Here, for bend allowance, we will select a key factor and make it 0.5. This means that when creating a flat pattern, SolidWorks will use the middle line, neither this outer line nor this outer line. It will use the middle line for making the flat pattern of the sheet metal. If this was 1, it would look at the outer edge or 0 inner edge. And for outer relief, in the corners where there is an overlap between parts of the plate, we will use a rectangular relief with 0.5 ratio. We can confirm this feature. And immediately, SolidWorks adds this sheet metal folder here. The parameters we gave in this base for the sheet metal part will be used during the entire modeling of this part here. Let's add the material. Right-click, Edit Material. We can use 355, for example. And let's save this part. Let's call it Housing 1. Now that we have the base, we can simply build up on it and add the remaining parts. Firstly, we will add 2 flanges in this area. For this, we can use the Edge Flange feature under the Sheet Metal tab. It's asking us for the edges where the flange will be applied. We want it here. We can drag and simply left-click. So automatically, it will be the same height as the one on this side. We wanted 90 degrees and 30 millimeters here for the flange position. Let me look at it from this side. You can see that when changing this, the position of the flange also changes. And we want it with material outside. This is the one we want. Let's confirm. So now you can see that it is simply extending the base we made, because we don't want these edges to be sharp, because someone could cut themselves here or injure themselves. We want to make these 2 edges here smoother. In sheet metal, you can do it by bending this side around this edge. We can do that by using this feature. It's also located in Sheet Metal tab. Let's select it for the edges. This is the one we want, and this one here also. And as in the edge flange, you can select the type and where the material is going to be bent. Let's take a look from this side. You have closed, open, teardrop, and rolled. In this case, we will use a closed one, and it's going to be 10 millimeters long. Let's check it on the other side. This looks good. The key factor is, by default, as we set it in the base tab, we created it as the first feature. Let's confirm this. Next thing we want is to create an opening in this area here. Firstly, I will create a center rectangle somewhere around here. Let's make it 110 by 110. Here, I want this point and the origin vertical. And this distance from the center of the rectangle to the origin will be 35 millimeters. Now I will draw a circle, starting from the center of the rectangle. Make this edge and this point coincident. Now I will use the trim entities. To keep trimmed entities as construction geometry turned on, I will delete this edge here, this edge, and this edge too. There we go. We have a close contour. So this pink contour will be cut extruded. I can confirm this trim feature. And now we can use extrude cuts under the Sheet Metal tab. Here it is. And there is a special option. You don't have to go here and select through all, up the surface, or so on. You can simply say link to thickness. And this feature is only available if you are in sheet metal mode. This is a very useful feature because I have to calculate how deep I have to cut something like that. This will be cut through the sheet metal. We can confirm this. Next thing we want to do is add another edge flange here. As we did for this one, let's go to the edge flange feature, select this edge, drag it upwards or wherever, it doesn't matter, and click, left click, then we will enter 45 millimeters, and also keep this material outside. Let's confirm it. And now we will just add another edge flange here, and use this edge, drag it towards the left, and make these 30 millimeters in depth. Also, material outside. Let's take a look at what they've done so far. It looks good. Let's save the part. Now we will add another flange edge flange here, but we want it a bit shorter. We don't want it all the way along this line. The way you can do this is by going to the edge flange, selecting this edge, dragging it. Then you can go here and say added flange profile. This small window here appears. What I can do is drag these lines. There are 3. It simply has this on edge, a converted entity relation. And I will add these dimensions. This will be 100 from the origin, and I have to select from here. This line will be 50. And here, I will say 45 millimeters, and then don't press escape or something like that. Simply press finish. An edge flange will be created. I just want this extended here and here. On the other side, the way I can do it is by making a sketch on this surface here. For example, I can start from this point here and this point here, make this coincident, and the same on the other side. We can say that these 2 lines are equal and make them 15 millimeters in length. And simply like using Extrude Boss, we can use the Base Flange tab. And you can see it, it's keeping the original 2 millimeter thickness of the plate, and we can simply confirm this command. So far, we have created this. We can add chamfers to these corners here. But instead of using a chamfer feature from this feature tab, we can go to sheet metal. Here we have break corner trim, and we can make this 20 millimeters by simply selecting this edge here, and this one here. It's as simple as that. There we go. Next thing I want to do is remove a part from this center of the bend. The way I can do it is simply by drawing a sketch on this surface here. If I look at it from this side, I cannot see where I'm drawing. So what I can do is make a cross-section in this plane. And now I am able to see what I'm drawing. We can start by using a corner rectangle and dragging it here. We can make the center of this line and the origin vertical, and make the horizontal line 100 millimeters long. Now, we can turn off the cross-section view. If I go to sheet metal and extrude cut, a link to thickness is activated, but it will only go up to this surface here because this is the surface where the sketch was drawn. We can add some holes in this part where the bolts will be used to connect the housing to some other part, so we can add 2 holes here in this area. I will make a center line, another one, and another one from the center of this short line. And let's add 5 millimeters in diameter circles. These 2 circles can be equal, and this is still blue, so it didn't connect to this vertical line. And now the sketch is fully defined. We can simply go to sheet metal, extruded cut, and select blind linked thickness. There we go. Let's add slotted holes here. And here, I will make a center line. Another one here. Let's add 2 more of them from the center of the horizontal lines. And now I can use a center slot. When I select these 4 points, SolidWorks will ask me if I want to make these 4 slots equal, and I want to do it. And we can see that these 2 slots are symmetric over this vertical line. Let's do the same on the other side. And now we can add some dimensions. From here to here, we have 55. Same on the other side. Slot is 15 millimeters wide and 8 millimeters wide in this direction. Then we have a fully defined sketch. We can go to sheet metal extruded cuts, and link to thickness is already selected. So we just have to confirm this. Now we can add some ventilation holes on the sides. Let's begin by creating a sketch on this surface here. I will create a center line from this edge to this edge here, and add a center slot from the middle. And let's add some dimensions. The slot will be 35 millimeters in length, 6 in width. And here, from this edge, we have 20 millimeters. Again, sheet metal, extruded cut, linked to fix. And since we don't want to waste time and make this same feature again and again, we can use a linear pattern. For direction, we can select any of these lines that are going in this direction. I will select this one, for example. Spacing for an instance is 15 millimeters. I want 9 instances. Here I will select features and then select this edge, which is connected to the extruded cut feature we used for creating the slot. We can simply confirm the feature. I want the same thing on the other side, so I can use mirror feature. For a mirror face, I will select the right plane. And for features, cut extrude and linear pattern. There we go. Let's just add 2 more holes for bolts on this surface here. We can draw a center line here and another vertical one. And let's add an 8 millimeter in diameter circle. Also one on the other side, which will be the same. And we have to say that these are symmetric. And if I don't want to see these relations while sketching because they are making visibility a bit bad, I can go to this drop-down menu and simply check this view. Now we can add this dimension, which is 60 millimeters between the centers of the circle. Again, sheet metal, extruded cuts, linked to thickness. And here it is. Another thing we want is a ventilation opening in these areas. We can do it by using this vent feature. But what it requires is a sketch. The sketch has to look something like this. Let's make a sketch on this surface. I will use the center line from this point here to this one. And let's firstly create a circle from the center of the line, make it 80 millimeters in diameter. Next, I will add standard lines, 1 vertical, 1 horizontal, and 2 more diagonal ones. Firstly, I need to make the midpoint of the line and the center of the circle coincident. The same thing has to be done on the other side, for the other line. And we have to add 1 dimension. Let's say this is 45 degrees. And since I don't want to add another dimension on this side, I can simply say that these 2 points are symmetric over this vertical center line. And now the sketches were defined, but I have to add 2 more circles from the center. The distance between 2 circles is 12.5, so let's make it the same here. And there we go. The sketch is fully defined. Now we have to exit. And since we have a sketch, we can go to the Sheet Metal tab and select Vent. For the boundary, we will select the outside circle, the largest one. And automatically, it will select the face where the vent will be created. Now for the ribs, we want them to be 3 millimeters wide. And ribs will be all of these lines here. So 1, 2, 3, and 4. Also 3 millimeters wide. And for these, we want them also to be 3 millimeters. So simply, we have created a very nice looking ventilation opening. Basically, we are now finished with modeling this housing. The last thing we can do is take a look at how the sheet metal sheet plate that we have to cut on our plasma cutter or laser or water jet will look in its flat state. So before bending, the way we can do it is going to the Sheet Metal tab here and selecting Flatten. And there we go. This is how this part should be cutted out in this 2 millimeter thick metal plate. And then you can bend right at these lines. As a result, you would get this part here. I hope you liked this tutorial. I'll see you in the next one.